to advanced trigonometry like in grade 11. Okay, now you know your four quadrants. You have been introduced to the reduction formula, right? So you should know that whenever you solve any trigonometric equation, the answers that you get also depend on the quadrant. In grade 10, you were concentrating on values of theta that were in the first quadrant. Okay? But that is going to change from now on. You need to know that any trigonometric equation has got many solutions. Okay? Any trigonometric equation has got many solutions because of the periodic nature of sine, cosine, and tan. They are periodic. Okay? The period of tan and sine, of sine and cos, you know that is 360 degrees. We also have to relate your knowledge of their graphs as well. That is the sine graph, the cosine, and the tangent graph. Now, because of that periodic nature, it means we can get many solutions. Okay? Now, in most cases, you are given a restriction, like last year when you were given a trig equation, you were told that theta lies between 0 and 90 degrees. So you're only getting one solution. Now that is going to change. So you need to be aware of the following, that sometimes you can get an answer which is in quadrant 2 depending on whether the ratio is positive or negative. You can get an answer in quadrant 3 also depending on whether the ratio is negative or positive. You can also get an answer that's in the fourth quadrant and it may be negative or positive. In all those cases, for the second and third quadrant, we use 180 degrees as our reference, which means if you get an angle from your calculator, you get an angle which is acute. It can be negative or it can be positive. If you want to get an angle which is in the second quadrant, you may need to add 180 degrees. Okay? If it's in the third quadrant, you may need to add 180 degrees depending whether the angle is negative or positive. If it's in the fourth quadrant, you may need to add 360 degrees to get an angle which is in the fourth quadrant. Right? So I'll show you some examples now. Okay, so the trig equation that we did last year, when you were using your calculator, shift cos, shift sine, shift tan, those equations, your knowledge is going to be expanded now. Okay? So let me do some examples. Now this is more like grade 10, we are not into grade 11 yet. Right? So let me do the first one. So 1a, you have tan theta equal to 2. Right? The question says solve for theta in the following, round off your answers to 2 decimal places. Okay? The answers that you're supposed to get here, they are for theta. And theta has got specific sizes between 0 and 360 degrees. But here our ratio is positive. So you should know in which quadrant tan is positive. It's the first and the what? And the third. So what that means is you're supposed to get 2 answers for theta. Okay? The ratio for tan theta is positive, therefore the value of theta must be in the first quadrant or the third quadrant. Can you sit straight? Right? So this is a restriction which says theta lies between 0 and 360. So the first thing that you do, you drop the tan and then you say theta equal to shift tan of 2. Or in actual fact, in mathematics this is pronounced as arctan. Okay, I know that as teachers we just say shift tan, that's on the calculator. But the correct mathematical terminology is arctan, like this. Arctan. That's the correct terminology of that tan minus 1. Okay? But we just say shift tan because that's how you do it using a calculator. So make sure you've got your own calculator. Alright? So you go to your calculator. Right? You press shift, then tan 2, like that. And then you get your angle. That's 63, okay, 2 decimal places, that will be 63,43. right? Now, is 63,43 between 0 and 360? Yes. So it means our first answer, we say therefore theta is 63,43 degrees. That's the first value of theta. But we also say, since theta is supposed to be between 0 and 360, there's another angle which also gives us a ratio which is equal to 2. Okay? And that angle is in the third what? Third quadrant. Therefore, we say or theta is equal to 180 degrees plus 63,43 degrees. And your final answer then will be 243,43 degrees. Right? So you get two answers. Yes, what's your question?
So, in the exam, when you take 10 to the other side, you have to write 10 and then
minus 1. Yes. That's what you were taught last year. Okay? And that's a great 10 concept. Last year when we were introduced to trig equation, the grade 10 teacher was supposed to have told you about it. Yes.
Is it necessary?
Yes. It is necessary because there's a restriction here. This is the restriction. It means theta lies between 0 and 360 degrees. Therefore, we need to determine all the possible values of theta. That will give us a ratio which is equal to what? To 2. Okay, let's test it. Let's test the two answers. So, if I have tan 63,43, okay, like that, you get 1,99, which is approximately 2. Remember, we rounded off that value is 63,43, right? Which this is 2, right? Let's try tan 243, right, comma 43. Right, that one there. Check this. Is 2 get 1 comma what? 999. Which is exactly the same value that we got when we use 63,43. Which means both values of theta will give us a ratio that's equal to what? To 2. So we are no longer in grade 10 where you used to get one value for theta. That is gone now. Throw it outside. Gone now.
So, where did the 100 meter come from?
All right. This 180 came from the fact that, remember your quadrants. Tan is positive in the first quadrant and the third quadrant. So if I have a reference angle which is acute, we call this angle here a reference angle. The angle that you get from using a calculator or by using a calculator is called a reference angle. When you press shift tan and then you put a ratio, that answer that you get, it's an angle. We call it the reference angle. So if our reference angle is 63,43, it's in the first quadrant. But tan is positive in the first and the third quadrant. So how do we get an angle in the third quadrant? We add 180 degrees to the reference angle. Okay?
So what are we doing?
It means you get one answer, so you won't get full marks. You have to know this part because it's in your Joule control test.
Okay.
Alright? Are you following there? Your knowledge of quadrants. Remember, I've told you in the past, right from the first day when you did trig this year, that was almost like 2 or so weeks ago. I told you that your knowledge of quadrants is more important in grade 11 than last year. You have to know your quadrants. Okay? So we have got two answers. We have two answers. Alright. Can I carry on for another example? Right. Let's do one which is a little bit more complex in terms of these trig equations. When I say complex, I'm referring to the ones that we have here, because you are going to encounter ones that are even more complex than this. Right? So let's choose, say, D. 3 cos theta equal to minus 2. Again, theta must be between 0 degrees and 360 degrees. Now you know that if the ratio is negative, cos must be in the second and the third quadrant. Okay? So for these questions here, you're supposed to get about 2 answers for theta. So 3 cos theta is minus 2, is equal to minus 2. So that's 1D, right? It's 3 cos theta equal to minus 2. 3 cos theta equal to negative 2, right? Our value for theta must be between 0 and 360 degrees. So the first thing is to make cos theta the subject. So you get 3 cos theta all over 3 is equal to minus 2 over 3. And that will give you cos theta equal to negative 2 over 3. Alright? Then we are going to bring in now shift cos. So when you take the cos to the right, you get theta equal to shift cos of 2 over 3. Okay? Then let's bring the calculator. So this will be shift cos of 2 over 3. Okay? Oh, sorry, it's negative. It's negative. I'll put the negative in front. So that will be negative. Alright, so we get that obtuse angle 131.81. 131.81. So it means the first value of theta will be 131.81 degrees. Alright? Now, can you stop that? Right, so this ratio here, it's negative. Okay? 131.81, if you put it where there's theta there, you get minus 2 over 3. Okay? Remember, if the angle is in the second quadrant, the ratio for cosine of theta will be negative. Okay? The other angle is in the third quadrant. Okay? Now, how can we get an angle in the third quadrant if we have a reference angle which is 131.81? What? What? We want the angle to be in the third quadrant, but our reference angle is 131.81. Huh? Listen. So you add 90. If you have an angle in the second quadrant, you want to get an equivalent angle which gives you the same ratio in the third quadrant. 90. What would you do? 90. Add 90. Add 90. All right, can you check out your calculator? Let's do it and see whether we'll get minus 2 over 3. So what you are saying is if I add 90 to that, right? So you are saying 221.81 is equivalent to 131.81 in terms of the ratio that we will get, right? So let's put that as a cos. So cos 221.81. Right? Sorry, you can't do that. You can. Hey, yo! Jesus Christ, right, so you get minus 0.74 is minus 0.74, the same is minus 2 over 3. Okay? No, this one is minus 0.66. Okay, that's minus 0.66. The calculator won't be able to convert that to a common fraction. But you should know that minus 2 over 3 is the same as minus 0.66. It's close to minus 0.67. Okay, so the answer is not 221. All right, just to make things easier for yourselves, to get the angle, yes?
Wouldn't it be minus 1? From the left thing on
So it's plus 180.
No, we want an angle in the third part, which is positive.
So the second is 180.
We want an angle in the third quadrant that's positive, which will give us the same ratio as 131.81.
180. That's 180, so that's 22.
No. Alright, if you want to get that angle, what you do is you just have to subtract this angle here from 360 degrees. Okay? You subtract this angle from 360 degrees. So the other angle will be theta equal to 360 degrees minus 131.81. Right? If you do a subtraction, what angle do you get? 220.19 degrees. Right? Let's verify if this is correct. Right? So if I find cos 229, 229, 228, 228, 19, you get minus 0.666. Okay, which is equivalent to minus 2 over 3. So in a nutshell, when you are dealing with cos, okay, if you have got a negative ratio, right? If you use that negative ratio to get an angle, you get an angle in the second quadrant. To get an equivalent angle which gives you the same ratio in the third quadrant, you just subtract the reference angle from 360 degrees. Yes?
How do you know in this bonus of completion you add 180 there? How do you know that stuff?
Okay. This is, well, to be honest with you, it comes from knowledge of the periodic nature of the graphs. That's number one. Also the knowledge of quadrants. So look here. You have got this equation, right? Cos theta is minus 2 over 3. The ratio is negative, right? When we use this ratio to get an angle for theta, the first angle, which will be obtuse, to be in the second quadrant. Now the next thing is to determine an angle in the third quadrant that is positive as well. Okay? So to get it, we can't add 90 degrees. You can use trial and error if you want. You can't add 90 degrees. You can't add 180. The only way that you can do is to say, okay, if I am in the second quadrant, if I want to get an equivalent angle, it has to be in the third quadrant. Therefore, subtract the reference angle. This is also called the reference angle. Okay? Subtract the reference angle from 360 degrees. That will give you an angle in the third quadrant. Okay? Then you can use trial and error if you want, if you are not 100% sure. Use that angle in the third quadrant where there is theta there, you should get the same ratio. So there's a combination of quadrants. Maybe you can trial and error together with your knowledge of the periodic nature of the graph. Okay, I hope you are aware that our next topic after this, when it comes to trig, is going to be the trigonometric graphs. You see, last year, when you were sketching the graphs for cos, you were only sketching them between 0 and 360 degrees. And this is how the graph of cos looks like. You're only starting from 0 to 360. But you need to know that the graph also goes like that. It's periodic in nature. Okay? So you are not sketching it to the negative side of the angle. You're only concentrating from 0 to what? To 360.
We did not.
No, you
We
did.
didn't do the negative side.
Listen, you didn't do the negative side. So check this. Can you pay attention? Because you are the one who asked. The angle here is 90 degrees. Right? The angle here is 180 degrees. The angle here is 270. Then here 360. Now check this. The amplitude, I'm talking about, this is the basic graph, of course. The amplitude here is -1, right? Sorry, it's +1 rather, we have -1. So, if I have -2/3, this one here, it's somewhere there, right? I'm just approximating it. Do you see that if I draw a horizontal line from -2/3, how many values of an angle will I get? 2. Do you see that one of them is close to 270, which means it's in the what? Third quadrant. And the other one is going to be in the what? In the second quadrant, but it's just after 90 degrees. Are you following? Now, generally, there is a relationship between your knowledge of trig graphs and trig equations. Okay? Are you following? So last year now, you were only concentrating on finding values of theta between 0 and 90 degrees. Because you were in grade 10. Right? Okay. Are you following them? Huh? Okay, let me carry on. Is there anybody who has got any question? Is there anyone who has got any question? And if you don't have a question, then let's do the next exercise. Right? So I've done two simple examples. Now let's do these ones here. These are also trig equations. They are similar to the ones that you did last year. So let me choose one with sign, like number 3. So we have 2 sine 2 theta is equal to minus 0.56. But now it says 2 theta lies between 0 and what? 360 degrees. Now I can solve this inequality. So if 0 degrees is less than 2 theta and 2 theta is less than 360 degrees, do you agree with me that I can divide that 2 theta by 2, the 360 by 2, and the 0 degrees by 2? Can you stop concentrating on that? So this becomes 0 degrees over 2, 2 theta over 2, and 360 degrees over 2. So we are simplifying the restriction so that we can get theta in between 0 and 360. So this will give you 0 degrees is less than theta and theta is less than 180 degrees. So I have simplified the restriction. Because I don't want to work with 2 theta, it's better for me to work with theta. So I've simplified that restriction. This should not be something that's surprising you. You did inequalities in grade 10, inequalities this year in term 1. So you should be able to understand that. Okay? I've simplified the restriction so that we no longer have this 2 theta, but theta, which means the upper limit is no longer 360, it's now 180. Okay? And the lower limit is still 0 degrees. Once I've done that now, it means when I solve this equation, I must get values that are between 0 and 180 degrees. So, let me solve it. First thing, divide both sides by 2. Please, when you divide by 2, if you have got a trig equation like this 2 here, the coefficient of theta, is not divided by the coefficient of sine 2 theta. So you only divide everything by 2, and then you get minus 0.56. This 2 and that 2 will cancel out. The 2 theta remains there. It doesn't disappear. So you end up getting sine 2 theta is equal to minus 0.56.
0.56
Yeah, it's 0.56 over 2. Alright? Then let's find the reference angle. The reference angle is the angle that you get when, okay, you use your calculator. That's the reference angle. Alright? So from here, you drop the sign on the left, you get 2 theta equal to shift sine of what? Minus 0.56 over 2. Now this is a negative. It means we need to consider the quadrants, okay, in which 2 quadrants is sign negative. It's the third and the fourth. So we must get 2 angles, one in the third quadrant, the other one in the fourth quadrant. Then we simplify. Then later, our theta must end up being between 0 and 180 degrees. So for now, I'm going to use this restriction. Okay? Then I'm going to simplify it for theta. Because the question is saying solve for theta. I hope you can see that. It says solve for theta. It's not saying solve for 2 theta. No, solve for theta. So from here now, let me use my calculator. So if I use my calculator, that will be shift sine fraction option, the negative 0.56 divided by 2. When I close my bracket, I'll get that. It's a negative acute angle. And that angle is in the fourth quadrant. But our restriction says 2 theta must be between 0 degrees and 360 degrees, which means I don't need that negative. I have to convert it to a what? A positive angle. Okay? Now, in order to get an angle in the third quadrant or the fourth quadrant, I have to either add 360 to it, okay, so that I can get an angle in the fourth quadrant, or I add one. If I add 108, I'll get an angle in the second quadrant. So what you have to do now is to subtract that angle from 180 degrees so that you can get one which is in the third quadrant. Okay? So it means 2 theta is equal to minus 16,26. This is not the answer. Right? Now I need to convert that angle to a positive one. Okay, and the first positive one, I would suggest that you can make that angle to be in the third quadrant, then move on to the fourth. Or you can start with the one in the fourth quadrant. To get the angle in the fourth quadrant, you add 360 degrees to that. Okay? To get the one in the third quadrant, you have to subtract this angle from 180 degrees. So let's do the first one where we subtract. So let me go to the next page. I hope you are following. Eh? So 2 theta will be equal to 180 degrees minus 16,26 degrees. Okay? And this minus, so that will give me 196,26 is equal to 2 theta. Then I need to find theta, that's the objective. So we divide, but before I get on, I just want to test if this 196,26 will give me the ratio that I get minus 16,26. And that ratio is going to be minus 0.56 over 2. So let me just check that. Right? Can someone divide minus 0.56 over 2? What answer do you get? Minus 0.56 over 2, what answer do you get?
Minus 7.
Huh? Minus 7 over 25. Okay. Now let me put sine 196,16 to 26. Right? Hope you are following me. Right?
It's negative 0.2.
Okay, I think you didn't follow it properly.
It is 0.10.
Minus 0.56 over 2.
Minus 78.
Which is that?
Minus 0.2.
2. Yes, which is the same as this one.
Yes.
Right. So what that means is that 196 it is correct. Right? I just wanted to verify. Alright? So I can now carry on to calculate theta. 196.26 over 2. So my theta, if I divide that by 2, so it will be 196.26 divided by 2. So I'll get 98.13. So that will be 98.13 degrees. So this is the first value of theta. And check this. Our second restriction after simplifying is this one here, which means our value of theta must be between 0 degrees and 180 degrees. And 98 is between 0 and 180. It's also positive. Then, to get the second angle, I still have to use minus 16.26 degrees. Okay? Alright? So what I have to do is add 360 to this angle to get the angle in the fourth quadrant. Right? So we'll end up having, I'll say, or 2 theta is equal to minus 16.26 plus 360 degrees. Let me see what that gives me. Right, so it will be 360 minus 16.26. That will give me 343.74. So 2 theta will be 343.74 degrees. Right? But I can verify if it's really correct. So I can put this in the calculator. I must get the same ratio that I got with 196. So if I say sine 343.74, like that, I'll get minus 0.2799, which is the same value that I got. So here I can carry on and divide both sides by 2, and then I'll get theta equal to, so that will be 343.74 divided by 2. So I'll get 171.87. He's not paying attention. 171.87. So this will be 171.87 degrees. Yes. Okay, are you a teacher? Okay, wait. Answer my question. Remember, I am a teacher. I need to show you how I got this answer. That's what I'm doing. So in your test, if you decide to not show all your working out, if there are marks for working out, you might lose those marks. Okay, and don't blame me if you lose those marks. Because if I'm marking, I'll follow the memo. You just write the answer. If there's a mark for the answer only, you get 4 marks. If there's 1 mark for the answer, you get 1 mark. You know that in math you have to show all the working out. So our 2 answers are going to be this one here and this one. Those are our 2 answers.
So for the question, are we finding the side